Hey guys, welcome to another video by Supernal Tutorials. In this video we'll be focusing on calculus on a subtopic called optimization and rates of change. Okay, so for this question we're given a water gauge. In the statement it is said that the height of the water is h centimeters. Okay, so this is our height. I couldn't demonstrate it here on the graph because it's actually a small drawing, right? And then we're told that the radius is r. So this line right here will be our radius, right? And then we're told that the angle between the cone edge, this is the cone edge, right? So we're told that the angle between the cone edge and the radius is 60. So this is the radius and this is the cone edge. So our angle is right here. We're told that it is 60, right? Okay. And then we also given a formula for calculating volume. Okay, so in our question we asked to determine R in terms of H and leave the answer in set form, right? Okay, so as you can notice, we're told that we should leave the answer in set form. This is a guide to tell us that our answer will be in set form when we do it correctly, right? And then for this question, don't pay much attention to the information because it will leave you distorted and not knowing where to start. So just take the question as it is. It says determine R in terms of H and leave the answer in set form. If you can notice right here, this forms a right angled triangle. The line H and R, they are perpendicular, they form a right angled triangle. Therefore we can apply trig ratios, right? Because we have an angle and we just need to determine R, right? So that's how you're gonna be able to know that, okay, this one I can actually apply trig ratios. Okay, so you're gonna say tan 60, right? As you know, tan, the trig ratio tan, it's opposite over adjacent, opposite over adjacent. So this is our angle. The opposite side is H, and then over adjacent. Adjacent is what? It's the length right next to the angle, which is R. Then putting this in terms of R, it will just be rearranging the fraction, and it will be like this. Then if you use your calculator, you will see that tan 60 is root 3. So as you can see, this is in set form. So you have actually determined R in terms of H. Okay. Don't pay much attention to all this information. I know it can be confusing, but it will actually help us in our next question. Our second question reads as follows. We asked to determine the derivative of the volume of water with respect to H when H is equals to 9 centimeters, right? Okay, so we asked to determine the derivative of volume, right? So we need the formula for volume. On our given information here, you can see that we're given 4 different formulas, but not all of them are correct. So for those who know the volume of a cone, it's easier to pick it out. But for those who don't know, I can at least try to explain how you can try to reason around it and actually select the correct one, right? Okay, so as you can see, let's check with this formula. It says volume is equals to length times breadth times height. As you can see on our diagram, on our cone, we don't have such dimensions. So automatically then it means that our volume cannot be calculated using this formula. And right on our second on this other equation right here, it says 4 over 3 pi r cubed, right? This formula, using logic, you can tell that we cannot possibly use this one, because with our question we are told that we need to determine the volume of water with respect to H. So this formula does not have H in it, so we cannot possibly use this one, right? Okay, and for those who know, this is the volume of a rectangular prism, yeah. And then this is the volume of a sphere. Okay, and then we come back to this one. This one says volume is equals to pi r squared times H, right? Yes, it does look like it's a possible solution, right? But it is incorrect, right? Because checking the geometry of the cone, we can see that the age of the height of the cone, as you go up, there is some change along the height of the cone, right? So between these two equations, we can see that, okay, this 1 over 3 can possibly be a factor that can at least try to account for that change in the geometry of the cone as it goes low. Yeah, that's how I would explain it. But just try and actually know your equations, then you can better explain these things. Otherwise, this is the volume of the cylinder, yes, and then this is the volume of the cone. Okay, so we're going to use this volume right here. So volume is equals to 1 over 3 pi r squared H. So guys, I'm gonna squeeze this in right here. So it says determine the derivative, so we're going to derive here with respect to H, right? So it means that this whole part right here, it will act as what? No, wait, I've actually noticed something, right? Another thing you should keep notice, I was actually about to answer it in the wrong way. You should realize that the questions are actually linked. So in the first question we were asked to determine R, right? So in this question we can substitute for R using the solution in the previous question. Therefore our volume will be as follows. When you substitute for R, it will be H over root 3 to the power of 2 multiplied by H. Okay, I'm gonna be forced to actually use another page so that, okay, so on our previous page we had that volume is equals to 1 over 3 pi r squared H, right? As you can see, this is a combined question, so all the parts of this question actually assist you to calculate the next question. So the first part we're gonna use to actually calculate the second part. So in the previous question we had that R is equals to H over root 3, right? So we can actually take this and substitute it into this equation, because remember we are differentiating with respect to H, so we need our variable to be H alone. So yeah, this is how it's going to be, right? And then when we try to actually simplify this, it's going to be, okay, so here we're going to have H squared, and then root 3 squared is going to give us a 3, because yeah, this is how you actually do it. you can actually even do this in your calculator. You'll see that it is 3. So if we're going to have a 3 when we put the square right there, then it means that it's going to be 1 over 3 times this 3. So it's going to be what? 1 over 9, right? And then times pi. And then if we check here, we have h, right? So h squared times another h right here. So it's going to give us h cubed. Then from this one, we find the derivative. So it's going to be this is how you denote the derivative. So it's going to be so this is our equation, right? So we take down the power, 3 over 9. So when you take down the power, it's going to be 3 times 1 over 9. So it's going to be 3 over 9 pi, right? Times h, 3 minus 1. We always subtract a power. You subtract 1 from the power. So this is going to simplify to 3 over 9. That's actually going to be 1 over 3 pi h squared, right? So this is our derivative. And then the question was to determine the derivative of the volume of water with respect to h when h is equals to 9 centimeters. So now that we have actually found the derivative, we can substitute in the 9 centimeters. So that it's 9 centimeters. We could have put it as h because that is our variable for the equation. So when we substitute 9, it's as good as saying we are replacing the h right there with the 9. So it's going to be 1 over, it was supposed to be 1 over 3, but it's still the same thing, right? Pi. Then when you substitute in for h, it's going to be 9 squared, as it is right here. This is the same as 1 over 3. So when you put this inside your calculator, you'll find out that the solution is 84.82 centimeters cubed. Remember, this is no longer the normal volume, right? So it is a rate, right? So when it comes to rates, you can actually divide by since we moved from volume to the rate of the volume, so it's going to be the volume value divided by the unit, which is centimeter in this case, right? Or you can actually, if you are unsure about the unit, you can actually put it as 27 pi. It's the same as 84.82. Then you can leave it like that if you're unsure of the unit.